Perfect.
Thanks, Ross. Yeah, next up, as Ross mentioned, is Skylar Knickerbocker. Skylar is a researcher and the co-director for the Real-Time Analytics in Transportation, or REACTOR laboratory. He works primarily in the areas of traffic operations, maintenance, and safety, including data analytics, data visualization, and big data management. In his role, he's led various research projects for the Iowa Department of Transportation, the Minnesota Department of Transportation, and the Federal Highway Administration. And with that, I'll turn it over to you, Skylar.
Perfect. Thanks, Mike. So I want to start and just kind of segue off of some of the things that Ross mentioned at the end, and that this has been a large number of groups and organizations that have been part of this, from the WZDx at the national scale to just in Iowa. It's been a lot of coordination with vendors and manufacturers like Ross and others, our contractors that are actually in the field deploying these devices for us to actually get this data. And then with a whole host of other data integrators and systems on the back end for how we actually use this data and distribute it out through the WZDx. So today I'm going to try to give you that story of why we did this in Iowa and what motivated us, and then what we're actually doing to use both the WZDx device feed as well as the WZDX feed. So if you can go to the next slide, and probably just skip my introduction slide to the next one. So really what motivated us in Iowa was this urge to know, what are all the lanes closed right now? And we ask ourselves that question, and the problem that Mike and Ross both said is we don't always know where all these are, and if there are, it's very inaccurate. So if we wanted to be able to get this out to the public, what steps do we need to take to be able to accomplish this? And next slide. And then just reiterating what Ross and Mike said is there's inaccuracies in the data. I often go to various state DOTs whenever I'm out traveling and presenting, and it's pretty easy if you can see both cameras and the work zones that they put out there, that there's inaccuracies. Here in Iowa is just a screenshot of one that I was able to find within a couple minutes, where we said we're going to reduce it to one lane, and the project was going to start at 9 p.m. But we're almost an hour later and there's no lane closure in sight. So how do we not lose the confidence in who we're providing this data to say, okay, we actually know whether that work zone is actually out there because we verified it, or it's just estimated because we're planning on working out there, but we don't know it's actually out there or not at this time. Next slide. And the challenge is we know that we can't ask our field staff to be able to provide this information. The motivation, or the kind of the comments a few years ago, or 10 probably years ago, was, well, let's just give them another form to fill out and tell us whenever they're out there working. But they're more focused on the concrete being laid, the rebar, getting tickets and different things like that, that this isn't their main focus of the traffic control and being able to have accurate information. So if you go to the next slide, where we then transition to is looking at ways that we can automatically collect this and using more of an IoT approach, where we have different devices and sensors out there that we know where they'll be placed, and that we can get that information off those devices to have confidence and verification that the work zone's actually out there, and improve the overall accuracy of our data. So using things like smart arrow boards that have been mentioned multiple times today, using other devices like these pins that go in cones, or panels that have electronic communication, or even just our AVL trucks that have this location information provided in them, where we can get this information of where they're at, what's their status, and we can have confidence if it's a work zone or not. And this is just a sampling of the devices. I'll talk about a few other ones that we're testing out at the end. But next slide. Where we really focused was on the smart arrow board deployment. And Mike said that we started small, and really the reason we started small was we knew that this was going to require commitment from our contractors, and it's going to require them to procure resources and be able to buy these devices and build up their inventory and fleet. So that's where we started on just the interstates, and wanted to test things out with just the interstates, and then further expand that to all projects in 2022. The other reason we started with the aero boards is because it really doesn't require any training or changes in the field. The people in the field are still just flipping the switch to what the pattern is, and then we just start getting that data on the back end to the DOT. And then the other nice thing was that we could modify all of our existing inventory, and it wasn't requiring all the contractors to go out and buy brand new aero boards. They could still use the aero boards they have and just adding on a component, which makes it smart to be able to communicate with us. Next slide. And then I like to throw this one in there. Really the only difference between the aero board, and I've already mentioned it, from a non-smart aero board versus a smart aero board. If you click the slide, it will show up communication. It's really just communicating from those devices to the DOT, so we know actually where those devices are located and what's the pattern on there, so we can have with confidence where the work zone's at. If you go to the next slide. And unfortunately, we started this effort before there was the work zone data exchange device feed. So we could only have dreamt of having a WZDx device feed at that time. So what we did was we actually developed our own kind of homegrown smart aero board protocol is what we called it. And that's what we use to give to the vendors to say, here's the data format that we want. And it's nearly identical for the most part in the to the WZDx device feed. But it was really kind of starting to lay that groundwork and really along the lines of what MassDOT was doing to really generate that device feed and get that aero board data in a standard format, regardless of what manufacturer was providing that aero board. Next slide. And so this is just a map that we give our inspectors, because again, as I mentioned, there's real no difference between a dumb aero board versus a smart aero board. And so we wanted to give our inspectors the ability to quickly see and verify that it is a smart aero board. So they can simply open this map, verify that they're seeing the location information from the aero board, and then that gives them confidence that it is a smart aero board and that they're meeting the specification that we require, or the standard for providing these aero boards on our work zones. We've ranged from typically 90 to 140 aero boards at any given time across the state, with the definitely peaking in the summer months, where we have those active aero boards across the state. Next slide. Now that talks about all of our devices, and I'm going to start to transition now to the actual work zone information, because ultimately it's great to get this data and to be able to have confidence that we know where the work zones are, and it's used throughout the DOT. But really our goal is to get the information to the driver, so that we can alert them ahead of time that there is a work zone ahead, and giving that confidence to the third parties as well, that we know that there's a verified work zone. So next slide. And how we've accomplished this is through our work zone data exchange. We received a demonstration grant in Iowa to create a WZDx, and really the two main points that we did through the demonstration grant was we first created WZDx based on our existing work zones in our ATMS. So it was a more fully featured WZDx that was provides the most latest data that is entered into our ATMS by our operators. And then the second part of our effort was to integrate these smart aero boards that I was talking about. So we can take that planned work zones that our operators are already submitting, marry up the smart aero boards that are associated to those work zones, and produce that WZDx feed that has the verified information of where those work zones start. Next slide. And this just summarizes kind of the benefits that we see of having the WZDx plus the smart aero boards. Whenever we have an aero board associated with a work zone, we show that the location is verified in the WZDx feed. So a third-party consumer that is taking this data knows that we have high confidence that there's a GPS equipped device out there that's collecting and providing that information used to update it. This system is also set up that if that arrow board leaves that work zone or goes outside of the extents of the work zone, then it gets disassociated with the work zone, and that work zone will go back to its estimated status or whatever it would have been if there wasn't an arrow board located there. So we still have the ability to show that estimated information, but supplementing that with the arrow board information. And ultimately, our goal is to have just improve safety and mobility through our work zones by being able to communicate to drivers most effectively what's out there on our roadways. So next slide. This is just kind of a peek behind what the operators see within our system. We do not have it automated at this point. We just have a manual system where the operators will enter the arrow boards just like they normally do. But now in that little red dash box, you can now see a smart arrow board option. So it's a one extra box that they can do to select an arrow board. And once they assign an arrow board to that work zone, as I mentioned before, it'll continue to update that work zone with its location. And if it's a reoccurring work zone where they work tonight from 8 p.m. to 5 a.m., it'll continue to follow it as they move that arrow board on and off the job and show it as a verified whenever it's actually out there and on the roadway. Next slide. And this is just a map. The map on the left is showing our 511 website, and the map on the right is showing that same arrow board dashboard that I showed previously. As you can see, the arrow board is being used to update the location within our 511 website. And then recently released about a month ago, if you go to the Iowa DOT's website, you'll start to see these little green check marks on all of the work zones. Anytime there is a green check mark on a work zone, that indicates that it's verified by a smart device. And also, if you click on the work zone, it'll provide that additional note there, shown in the top left corner, saying it's verified by a smart device. And if you click on that, that'll give you a little more details about it. This is public facing, so we had to remove some of the technical aspects of it and just be able to give them the basic information of what it is. But it's just another way for us to communicate out the work zone information to a different audience beyond just the WZDx, but using the same system on the back end. Next slide. And then this one I just threw in showing that what the WZDx feed actually looks like. So you can see highlighted there in green is where I've been talking about us verifying that these work zones are out there. So that's the primary field that's being updated or changed from estimated to verified whenever we do have a smart arrow board associated to the work zone. The one thing we are missing is we don't have verification of the end location, so we still rely on what end location was inputted by the operators. But that's an effort that we're still trying to focus on and get better data to get better devices out there to collect that sort of data. Next slide. So I just wanted to highlight a few of the challenges and lessons learned that we had. The one challenge that we had was, even though we had this standard protocol of how we wanted to communicate device or data from the smart arrow boards to us, not every agency or manufacturer provided the same level of feed in a sense. There were some that required put security credentials behind it, or more advanced security credentials, which required additional effort. There were others that were rate limiting how many devices that we could request at a time. While there were others that just provided a data feed that was open and available for us to easily download. So we had to work through all of those things to get those integrated, but it was just one challenge that we had to overcome as we're doing this. Next slide. The other challenge we had was, because we are manually assigning these arrow boards to the work zones, there's no our initial expectations that operators would see them on the map and be able to associate them to a work zone. But that wasn't really how it was actually being handled. So we identified a need for setting up alerts. And so now we have alerts that are set up where if an arrow board turns on and it's not associated to a work zone and it's on a state roadway, then we provide that alert to the operator saying, hey, here's an arrow board. If there is a nearby work zone, we recommend what that arrow or what work zone it should be associated with. If there's not, then we just tell them maybe a work zone should be created because of that. We also have a variety of other checks that are done. I think we have 8 or 9 in total, from integrating arrow boards if they're not integrated, to providing alerts if we have an error board associated to a work zone that's not showing up there. So we really needed this to help support the overall system. Next slide. For next steps, connected portable traffic signals are where Iowa DOT is focusing right now. I mentioned before, for the error boards, we only dreamt of a device feed. Now that we're here and we have a WZDx device feed, that's what we're using. So it made our process a lot easier. We're updating our specifications now that will require a WZDx device feed for connected portable traffic signals. We're going to do testing next year and then start requiring them in 2025. Again, this long leeway is really just to give the contractors enough time to be able to start procuring the secure equipment for us to test it and really hit the ground running in 2025. Next slide. And this is just a slide showing all the different devices that we're also testing. We've been focused on the error boards and connected portable signals because they're easy and low hanging fruit. But there's a lot of these other devices out there on the market that are going to be coming to Iowa and to other states, where we can actually use those and integrate these into our data feeds and into our WZDx work zone feeds. Just a few to note are the portable rumble strips from Icon. They provide a box for you to locate those. There's things that go on the back of signs that whenever you set them down and whenever you put it up, you get a notification that the sign's been put up. So we're looking at that again, provide the start location for work zones where we don't have smart arrow boards. And then also just using our AVL equipment where we know where those devices or where those trucks are located. If they meet a certain criteria, we can safely assume that they're in a maintenance operation that we can then provide out through our WZDx device feed. Next slide. Yep, I think that's it. And so I'll pass it back to Mike and go with Jacob Brady.